This problem says, list the different combinations of heads and tails that can occur when 3 ordinary coins, don't let them throw you when they say ordinary coins, that just says it's not a two-headed coin. When 3 ordinary coins are tossed, use H for heads and T for tails. I find it easier to picture what's going on if you kind of think of it more in terms of throwing 1 coin 3 times instead of 3 at once. When you toss a coin, if we use a tree diagram to illustrate how this works. With a tree diagram, you've always got some point which is basically start here, or you are here if you're looking at a map. So initially, on the first coin, there are 2 possible outcomes. It can land on a head, or it can land on a tail. Simple. Now, the way it landed the first time has absolutely no influence on how it's going to land the second time. So if we toss this coin again, then again, it could land on a head or it could land on a tail. And if it was a tail the first time, it could land on a head or it could land on a tail. And once again, the third time we toss it, it can still land on a head or it can land on a tail. Nothing's changed. Regardless of what it landed on before, it could land on a head or it could land on a tail. It could land on a head, it could land on a tail. It could land on a head or it could land on a tail. So we've got a head tail here. We've got a head tail here. We've got a head tail here. There are actually, with 3 tosses, 8 possible combinations. And if you follow each of these branches, you can see that here, this represents a head and a head and a head. So it could land on heads 3 times. Or it could land on head and tail. It could land on a head and then a tail and then a head. Or a head and a tail and a tail. The first one could have landed on a tail and then get heads and heads, or tail, head, tail. Well, how would you get to here? To get to here, you'd have to go tail, tail, head. Or to get out here, it would have been tail, 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 3 tails. Now, there are 8 possible combinations. 1, 2, 3, 4, 5, 6, 7, 8. And you'll notice that if you do it once, there's 2 possibilities. And if you do it twice, there's 4 possibilities. So that could make you think that if there are 2 possible ways for it to land and you do it twice, you should multiply 2 times 2 to get 4. And following that logic, if you had 2 ways to do it and you did it 3 times, then there should be 6 over here. But there's actually 8. Each tail here gets split twice. So the first time you have 2, the second time you have 4, the third time you have 8, 2, 4, 8. What's this pattern? This is 2 to the first, 2 to the second, 2 to the third. The only thing that would make the 8 work would be if you're using exponents. And if you did it a 4th time, you would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You'd have 16 different possible combinations, which is 2 to the 4th. The number actually doubles each time. Now, what they're asking us to actually do in this problem is to list the combinations. And one combination would be HTT, so that one's already listed. So what they're asking you to do is list head, 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 tail, head, all of these, the other 7, because it says list the other combinations, taking order into account. If order did not matter, if 2 heads and a tail was the same each time, notice that there's only one way to get 3 heads, 2 heads, and 1 tail. There are actually 3 ways to do that. Here's 2 heads and a tail. Here's 2 heads and a tail. Da, 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 da. Here's 2 heads and a tail. That's it. There are also 3 ways to get 1 head and 2 tails. And then to get 3 tails is only 1 way. So 1 and 3 and 1 adds up to 8. So you can answer all kinds of questions about this. The tree here, they call it a tree because it goes off into all these different branches, and out here we're pretty much down to twigs. But that is just a way to make sure that you've got all the possible combinations listed. If you're just trying to memorize a pattern to do it, and you can memorize a pattern where one way would be head, tail, head, tail, head, tail, head, tail. The next column to the left is head, head, tail, tail, head, head, tail, tail. The third column to the left, here we change every time, here we change every other time, here we change every 4th time. So head, 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 tail, 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 tail. If we were doing a 4th time, we would do 8 heads and 8 tails, and each of those would have this pattern repeat next to it. So that would be the 16. So they can ask all kinds of questions. They can ask you how many combinations there are. They can ask you, like they did here, to list them. They can ask you, how many ways are there to get 2 heads and 1 tail? If you can set up the tree like this, then you can answer all kinds of questions. So it can be really super useful. And we will be using trees a lot more after this too. So it's a good thing to need to know, to know how to do. Thank you. I'll see you later.